Okay, so at the end of part one, we left off around here. We modeled some construction lines, a basic framework, and the primary structural beams that run across. The next step is going to be to model the secondary structure that goes lengthwise or longitudinally across the arched beams. And you can see that better here. There's a series of them that run across at a certain kind of interval. And what we need then is to extract some information from our beams in order to kind of place and float these linear pieces across. So let's get working on that. Now keep in mind that what we did before is we put a cross section of a particular dimension at the end here, and that was, I think, 16 inches tall. But we fattened it up a little bit in the middle. So this is 21 inches tall, meaning that the arch that's at the top of this beam is not the same curve as the center line that we used to sweep and create the arch. So it's not as simple as just offsetting that arch to find the line where we want to start placing that secondary structure. So in our construction layer over here, what I'll do is extract those curves from the poly surfaces that we just modeled, and just due to how we modeled this, there's a dead center line that's right down the line here of the poly surface, which is nice. So we can use that to our advantage. So let's type in extract, and the extract command, there's many of them. We're going to use extract isocurve, and then select the top surface of these poly surfaces or the arches, and I'm going to snap that to the middle against the construction line that goes vertically, or even the green, the blue profile. Either one is fine. And that's going to snap that ISO directly to the center of that surface. So this is going to be a repetitive process. I'll do one more as a demonstration here. And I'll do one more just to show you what may happen on some of your screens depending on how you model this. It's possible that the direction is flipped in the V. So if you're seeing this, pay attention up in the command line. What you can do is click V, change that to the U direction, and you can go ahead and start working. Okay, so you can pause it now. I'm going to keep working and run through this. I'm going to go and find my curves all the way up to the center, and then I'm going to mirror it around to the other side like I did before. Okay, so that didn't take too long. I've got them drawn. I'm going to lock my primary beams layer and just select what I just drew like this. And the last couple here. Okay, just mirror it using that center line from before. Oops, not there. Mirror it from here, of course, from that center line, the midway point, and there we are. Okay, so if we turn off the primary beams layer, you'll see now that we have a kind of an offset set of red construction lines off of our original blue center lines, and we're going to use these to get started. What we'll do is we'll have to divide these into a set of points that will connect the dots across and create basically a framework from which we will start sweeping those secondary structural pieces. The first thing we need to do, though, because we've extracted the curve from a surface, we didn't draw it naturally using control points, we should probably check to see what it looks like in terms of its curvature graph. See if we need to rebuild it. So on my screen you can see that this one is quite nice. The other ones, they start to kind of tighten up a little bit in the middle, meaning that they don't have an equal distribution. A little bit later on down the line this will matter. Right now it kind of doesn't, but just to, for good habits, I'm going to go ahead and fix that just with a rebuild. So what I'll do is first I'll take all these and remove them, and I'm going to select all the construction line curves that I just drew in my most recent step. And you can do this faster if you had your section layer locked down like that. Okay. So there's my curves. I'm just going to type in rebuild. And I'm going to change the point count for every single one of these curves to 10. Okay. And then if I have another look at, let's say, the first few of them, turn on my curvature graph, you can see now that we've got a nice, pretty even distribution across in terms of the control points that exist along that line. And when we build surfaces, you know, we like to see stuff like that. All right, so there's the first test. The next thing we're going to do, because this is the first step, what we want to do is we want to find another offset from this point, because what this line is the top of our primary beam. And since we're not modeling every single detail of the building, what we're going to want to do is float these secondary structural members up and over the top of the beam. So I want to give a little space here, even though we're not going to bother modeling these brackets for now. But I still want to model it with a little bit of space there, so that I don't have any intersections, and so that if I did want to go back and add this detail later, I could. Okay. Okay. So let's turn off the primary beams layer. I don't need to see that. I can turn off my curvature graph as well. What I'm going to do is something simple. I'm just going to offset these lines. Staying in my construction layer, I'm going to type in offset. And the distance is going to be 5 inches. It's just a kind of a guess that I'm making. So I'm going to type in 5 inches. That should be enough of an offset for us to keep things kind of non-intersecting. And you can click it, and you should be able to do this in 3D. It's clicking right away to the top, you know, the positive Z direction offset, and that worked. Brings it right to the construction line. I know that I've got a nice clean offset happening there. So you can go ahead and pause this here and go ahead and work. I'm going to offset all of these red lines, and we'll continue after that. Okay, so here we are. Everything's offset. You can see it down the line. What I'm also going to do is check, once again, the curvature graph. And it looks like I may need to rebuild these as well. I want them to match the curves that I used before. So what I'll do is select the ones that I just drew. You know, just kind of running through that. Doesn't take too long. It's not too painful. Okay, and I'm just going to run a rebuild on that once again, keeping the point 10 intact and matching, making sure that my curves are nice and matched, and they should be perfect at this point. Yeah, looking good. Okay, so good quality curves. We can keep going. Okay. All right, the next step is going to be to divide that upper offset, the top one, because that's going to end up being the center of our secondary structure. So I'm going to select all those again, and you know, if you're clever, unlike me here, you could the last time you selected all these, you could group them. I was too lazy and I didn't, so now I have to reselect. So if we group them, it'll be easier to select later. So you can go ahead and group those, that's fine. So now when I select that, I select them all at once, which is kind of useful. So I typed in group and I grouped them. And what I'm going to do then is run the divide command, because I want to locate a series of points along these curves where I'm going to start placing my cross sections for sweeping. And this time the number of segments is going to be, let's try 10. I believe that's where I want it to be. And hitting enter, you're going to notice that we've drawn a series of points along every one of those curves, and they're equally spaced depending on this, the length of the curve itself. So you can see that you know, it's curvature dependent, which is good. And that's going to give us a set of 4, basically on either side of the structure. So from this side down, we're going to get a series of 4 secondary structural kind of lines, if you will. that are going to run all the way down the line and across. And let's draw a profile for that. So we can go to our profile layer, head back over to our interpolate point curves command, kind of like what we did with the blue lines before, and we're going to start connecting the dots. We could probably use this one, although not right away, but we'll use it later probably. And here you want to be careful so that you're not snapping to things that you don't want to be snapping to. You want to go point to point, you know, and take your time with that. Okay, so I'm going to finish this first one here. And mid-command, if you're getting a goofy zoom, you can hit Control-W and drag a window around where you want to focus. And that doesn't end the command. It's a really nice workflow trick. All right, and I'm going to draw this all the way across from end to end for this one, but I think you can probably just mirror it if you wanted, and then join later. Should be okay. The curvature remains the same, and that's what we're going to use it for. Control-W, making sure I'm seeing the point that I'm snapping to each time, you know, so I can be as precise as possible here. All right, so there's that one. And to make this go a little faster, I'm just going to rerun that command, and this time I'm only going to go halfway, point to point, and then I'll mirror it. It'll just be a little quicker. Okay, point to point. We can take it to the center here like that. Mirror that around anywhere along that line will be fine. And we've got a continuous line, and I'm gonna go ahead and join that so that when I select it, it's continuous. Okay. And I'll do one more, and then you can pause it and keep working. So I'm just going to do one more here. Connecting the dots, nice and simple. All right, go ahead and pause and continue and finish the whole entire structure. So you can, if you modeled just this one quadrant, you can mirror that around to this side. And then you can also mirror the entire side around to that side. I'll show you that in just a second once I get it finished up. Okay, so I got those modeled going across. I'm going to grab my end one and then select all the others. And I'm just going to go ahead and mirror that around from this line instead. All right, from there, bring that around to the other side like that and save myself a good amount of time. So now I've got my, pretty much my full cage modeled for this structure, aside from a couple of more elements that we'll need later. Okay, so we have those modeled, and we're going to use those in a minute, not right away. So go back to your construction layer, turn off your profiles. We have a series of points, and what we need to do is locate a perpendicular cross-section along each one of these points, kind of like what we did down here. This is where things get a little bit tedious and where the use of Grasshopper will be very useful later on. So what we're going to do is, first of all, we're going to keep ourselves organized. We're going to make a secondary beam layer that we're going to use later. Okay, and I'm also going to make a secondary beam construction layer. Okay, and we're going to activate the secondary beam construction layer. I'm going to make it green so I can see it, and this is the one that I'm going to use. I'm going to try to organize my construction layers now between things that I've used to generate the overall cage in the first set of beams, and now I'm going to separate it out for the secondary beams. And what we're going to need to do then is kind of run that line command again with the perpendicular option on. I'm going to click to each one of these points. You know, run the F command up here from first point. I'm going to make these all 2 feet, and I'm going to make them perpendicular. I'm going to run that a couple more times for you guys so you can kind of get the hang of it. Perpendicular before we click. Here, type in F, 2, Shift, click. P, click, F, 2, Shift, click. It's tedious, but this is what needs to be done in order to model this accurately. You could run a sweep along those profiles that you drew before from, let's say, one cross-section here, maybe one in the middle and one at the end. And what that's going to result in is a twisted beam. And that's not how this is constructed. These are steel straight extrusions. They're probably rotated away from one another ever so slightly, and this detail can pick that up. I don't know exactly how this is constructed, but I'm assuming that there's a detail in here that allows for a little bit of forgiveness with regard to the form, because here you've got a cable which can easily sweep through this cylindrical connection and be curved. There's no twisting involved here because it's a cylinder. This is a different story. This is a harder thing to build because the angle at which it is offset from this beam is not the same angle that it's offset from that one, and that's going to give it your twist unless you have something in the detail to support that. So I'm going to show you a way to model this piece by piece, but the first thing we need is a profile at every single one of those points. Okay? So go ahead and pause and work on that part. And remember, you can model it in quadrants. So you're going to end up doing just these points here. You don't have to do it at the end because those lines already exist. In fact, we're not going to put a structural member there anyway. So just this one, so just 4 points on each line in between the center and at the end. And then what we can do is mirror it around, save some time. So go ahead and pause and work on that. Okay, so we got that quadrant modeled. It didn't take too long, but it's not exactly fun. But what we want to do now is just rotate these things around. Come to think of it, you don't have to mirror these, actually, because we can use these to model our secondary structure pieces and actually just mirror those around instead of mirroring all the construction lines. If you wanted to do a drawing, for example, though, that showed these construction lines for whatever reason, let me just show you a little trick for that. You can type in select layer, select the layer that we just drew all those on, go ahead and do our mirroring, and what that's going to do is make a little bit of a duplicate over here, and we'll fix that in just a second. So that select layer enabled us to quickly select all of that. Run the command again. Select that same layer. Now we got all the rest. And we can just go ahead and mirror them around here. And in order to get rid of the duplicates, we can just say SCL dupe. So select dupe. It found 3 of them. Delete them. And we should be good. Oh, looks like there are some duplicates here still. Interesting. It's not selecting those duplicates. Okay, well, that's a method that I use pretty often, the select duplicate command. I'm going to go ahead and just Control-Z this a couple of times. And there we go, that's fine. Now I have just my quadrant modeled. The last thing I need to do is just draw a line up from the center here as well. And we don't have to use the line perpendicular command for that because these are all just straight lines. So in a different view, I'm going to draw a line straight up 2 feet like this, and then I'm just going to copy and paste it. Okay, so I'm just going to click to all those top red points along this center line that basically splits the entire structure in half. These are all straight on, so we'll just fire these up like this. Probably don't even need these, but just for the sake of argument, we'll model them just in case. Okay, so we've got our perpendicular lines that we're going to use to orient, and you can see them here. We're going to use these to orient a structural profile, section curve, as the sweep command calls it, along each one of these points. Okay, so we're going to go to our beam curve layer, the blue one, and in my right view, down somewhere below the structure, I'm just going to draw another rectangle at 6 inches by 6 inches, like this. And then I'm going to move this from its center point using the O-snap to the first point along that green line there. And then I'm just going to run the rotate 3D command like we did before, holding shift, clicking along my X, snapping to the midpoint, and then, let's try that again. Something came out goofy there. Snapping to the midpoint, and then snapping that to my green line. And now we're off and running. So this is our process that we used before, and I'm just going to do this down the line for each one of these. Yeah, and they're going to get closer and closer, so be careful. Make sure you snap to the midpoint. You know, on this one, there's not a lot of curvature in this red line here, so you know, they're going to be really close to perpendicular as it is, but the other ones won't be that way. So let's do this. Snap to the mid, wherever that is, and rotate it into place like that. Do it one more time here, and then go to the next line. So I'm going to copy this one. I'm going to rotate 3D here. Snap to my midpoint and pop it in. Okay, you can pause here and keep working until you've got the entire quadrant modeled. Okay, so once those are modeled, there's one last step, and that's not to forget the center line, you know, all the ones that are straight on, up and down in the Z direction. And I've drawn one here, and for this one I don't have to do any rotate 3D. I just wanted to remind you that these can just be copy and pasted, only up on this top line here, the top line there. If I turn on my profiles, yeah. So along that top line, all of these could be just a straight copy and paste. Okay. All right. So the last step then, before we start drawing the actual structural members, is what we're going to do. Yeah, we're going to explode this polyline that we drew before. As a matter of fact, I made a mistake, come to think of it. So what we're going to do, actually, instead of these control point curves, remember we ran through and we ran these as interpolate point curves. Actually, what we need in this case, because we want these to be straight on extrusions, is these need to be polylines, which are built of straight line segments. So go ahead and delete those from your profile layer. Head back into your profiles layer here, and then just click polyline. And what we're going to do is create straight lines in between, which will give us, when we do the sweep, a straight pipe extrusion, right? A straight extrusion, which is much more accurate in terms of the construction system used for this building. So I'm gonna walk you through that because it shouldn't take too long. Um, and I'm just going to draw these as kind of straight line segments to the middle, like this. And then I'm going to just mirror it. Oh, I can't mirror it just yet. I still need to draw the others. And then I'll mirror everything together. So let me just fire these up. And you can go ahead and do this as I work. Okay. All right, and I'm just going to draw one more at the top here. So I guess we'll need that as well. And this one we don't have to explode. This one can be continuous, and I'll show you why in a second. All right. Sorry about that. Back to it. So in this case, what we want to now do is explode these polylines into separate segments. It's just a little faster to draw them as polylines and explode them than having to run the command over and over again. So I've exploded these into hopefully separate segments, and you can see that they're separated in between those lines. But let's double check to make sure that it's continuously separate. And you can see that in some cases when the curvature is lessened, like over here, or the twist I should say is less, you end up with actually coincidentally a straight line across, which means, or at least within our tolerances. So what we have to do in this case, I suppose we can leave it in this case, but you're still going to end up with a little bit of a twist if you model it this way. So to do it correctly, I'm going to show you how to do that. I'm just going to take the segments that are left behind that are actually more than one bay long, delete those, and then I'm going to just make sure I kind of redraw the point-to-point as separate commands so that I'm guaranteeing that these are now separate line segments all the way across. Because when we do our sweep command, we're going to want to sweep between these cross-section curves, not across one-to-one, not necessarily all the way down the line. And that'll mean that there'll be no twisting in our swept poly surface that's representing the steel secondary structure that cuts across longitudinally of the roof canopy. So again, separate little segments, and we're ready now to start 3D modeling the steel structure. So let's go to our second beams layer. I'm going to lock down the construction layer, keep profiles on, lock this one down, and just keep on profiles, beam curve, the blue one, and secondary beams is where we're currently drawing within. Okay. All right. And let's start from the center and go back this way. So type in sweep 1. Your rail is this line here, and that's your cross-section curve, the one that's behind, and that's it. And let's do that again, and this time selecting this blue line, not the surface edge, but the blue line to do the sweep. And let's do that all the way down the line, and you'll see that when we get closer to the other end, there's going to be a change in rotation. And I guess if you zoom really closely in here, you can kind of see it. So this is what I mean. This is good in this model. It's meaning that there is no twist in these extrusions. You can kind of see that there. So if this were built from steel, you'd have no problem. You just cut it and miter it and call it a day. It's assumed that there's an offset between these and there's a detail in here that can pick up this issue. We're not modeling that, so what we're going to just do is kind of model these things as straight as we can. Like this. And as we go around to the other end, you'll start to perceive that change of angle a lot more obviously. And you can kind of get a sense of that kind of here a little bit more. Yeah, you can see it more clearly there now. So long as you're selecting the blue line and not the polysurface edge to do the sweep. Okay. I'm almost there. One more left. All right. Yeah. So there you have it. So there's a rotation that we've allowed for in order to keep these things straight. And you can pause here and go ahead and model the remainder of this quadrant of just these four, maybe the 5 lines, including the center line. You don't have to do the end. We're not going to put one at the end. You know, if we take a look at this image, it's just the cable at the end. The first steel piece comes inset a little bit, so you know we don't have to worry about the end one here. We'll use that one later for something else. Okay, so go ahead and pause and do the same thing. Start in the center line. This is your cross section. That's your rail, cross section, rail, and so on and so forth. Okay, so we have those modeled, and what I want to do then is just select that layer. Secondary beams, type in cap, that puts a cap on all of them. I can start my mirroring like we did before, mirror those around, select that layer one more time, mirror everything around the center line, and the only one left is the one down the middle. And this one, again, I don't have to break this into separate segments because there's no rotation between the sections. So long as these are all separate. Yeah. You know what, so I'm gonna join those back. Looks like I exploded it by accident before. And that's fine. So now what I can do is just run the sweep command. This is my rail. And I'm just gonna select. So it's one rail all the way through as a polyline. And I'm just going to select, just to be sure, all of these cross-section curves. To be 100% sure that they match, you know, where I want them to. And that's that. So that's going to create a bunch of non-twisted and basically straight segments, you know, going through all of those cross-section curves like we have here. And then we can just have to mirror this one around. Okay. Oops, wrong mirror point. Yep. Mirror it up here. From there. Mirror that around like this. And good. All right, and there you have it. The secondary structure is modeled. And the next step will be the tertiary structure, which is the pieces that hold on the skin, right? So here's our primary structure, right? These big arched beams. The secondary structure is this element that we modeled in here, the steel element. And those steel elements, while providing some more rigidity to the structure, it looks like they also hold these smaller bent arched beams that go, again, in the short direction, and those are floating off, you know, a bit of this. They don't touch the arched beams; they're actually offset from it. They kind of straddle it, and in between those, there's the copper skin, and in between, on the short dimension, there's glass. We're not going to model the glass. We're just going to kind of just launch into the surfacing just by modeling these surfaces as continuous for now, and then the next tutorial we'll pick up on how to break that down into panels. But for now, we're going to focus in on just modeling in this tertiary structure and the skin that attaches to it. Okay, so to find that offset, what we want to, again, what we're going to try to start doing is drawing these curved beams, the smaller ones here. And we know that there's an offset not only above this little steel piece here, but also away from the primary structure, right? So to the side of it, so that it kind of hangs on both ends over here and over here. So what we're going to do to find these lines, instead of offsetting and then kind of offsetting twice, we're going to, which would be fine probably, but we're going to incorporate one of the older methods that I showed for the boats, which is to draw a surface first and then section that surface. So let's run through that, and I'm going to make a cladding layer for now, and I'm going to use it to draw a construction surface that I'll just end up deleting later, and I'm going to make that layer white because it's easier to see the surfaces that way. I'm then going to loft a surface, and I'm going to have to unlock my construction layer here to do it, but I'm going to loft a surface through, remember that group that we made earlier of all of those construction lines that centered our steel beam elements? If you don't have those grouped, you can just go ahead and reselect them, but it's the ones that go across center-wise here. I'm going to just go ahead and loft those together to make a surface like this. And because we went through all of those curves at once, I'm just going to move this for you real quick and show you how it's nicely drawn. You can see the isocurves. There's an isocurve at every intersection, every section. So that surface matches our structure very nicely. So I'm going to go back in like this. And then I'm going to find the offset, because of course this intersects the other structure, and that's not tall, that's not high enough. So what I'm going to do to find the offset for those curved beams is to just simply offset the surface. So I'm going to type in offset surface. And my screen is showing the direction of the surface to have a downward direction, so I'm going to type in F and flip that. Okay, which is the same as clicking this button up top here, flip. I'm going to turn off solid, so that says solid no up at the top here. And then the distance we want to be, let's just say 7 inches. Should give us enough clearance. And then hit enter. And then you can hit enter one more time. And then delete the old one. So our new surface now, as you can see, floats over our steel structure so that there's no intersection at all. This is going to be the surface that we're going to use to base our curves against, the ones that go across the holes of the skin. All right? So we got to take sections, and we're going to need to set up a little bit of a construction zone to the left over here to take those sections really accurately, so that they're centered. And to do that, I'm just going to copy these points that go along that, basically the endpoints for the group that we just used in order to make the surface. I wish I had these grouped, but I don't, so I'm just going to select them manually. There are better ways to do this, or faster, I should say. Maybe not better, but faster. But this will result in a nice kind of clean set of construction lines that we can understand as having an origin. We know where they come from, and sometimes that's helpful. All right, so we're almost there here. Select those points, and then I'm going to select this profile here because it could be good to have, and then I'm just going to copy it out. So I'm going to type in copy, hold down shift, and pull that straight out in the negative y-axis like this, and just make a copy of that like that to the side. All right. And now the reason why we need this line is because we're going to find the intersection from a sphere that we're going to draw here to find our offset along this line and use those points as a way to develop our sections. So while I'm in my construction layer, I'm going to draw a bunch of spheres. So I'm going to type in sphere. Okay, and I'm going to click one of the points. And then I'm going to set my diameter to 2 feet. And then I'm going to copy that. Make sure it's not radius, make sure it's diameter. Because that's going to be the distance. It's my offset, basically. It's 1 foot on either side of the center of the primary beams. Or 2 feet on center apart is what those curved little bendy pieces are going to end up being. And I'm going to just copy the spheres across like this, and I'll show you why in just a second. You know, the thing is that what we've done is we've copied the curve out. So we want to, and if we want an evenly spaced set of section lines, we need to find the intersection of the intersection between the sphere and the line here to do that. So what I can do is, let's see what happens if I select last. Yeah, so if I type in select last, that'll give me the result of all my copies. I can also select that, and then the curve, and type in intersect. So intersect is now going to give me a series of points, as you can see here. And those points I'm going to use to start drawing my sections across. At this point, you could probably delete this if it gets in the way, or you can delete your spheres. I'm not going to do that. I'm just going to leave it. I'm going to draw a bunch of construction lines instead across. I'm going to draw one of them like this from the center, long enough, because it'll be easier in my top view. I'll show you. When I start taking this section, it'll be easier. So I'm just going to copy this line to every one of those intersection points like this. But I don't need to go on the other side, remember, because I can mirror those. So long as I got the center figured out, from center to the other end, I don't need to copy everything. You know, which also means I didn't need all the spheres, but I did it just for the sake of demonstration. All right. Just keep going. And end it there. Okay. I'm going to go into my sections layer, the blue one, go into my top view, turn this to ghosted, and then I'm going to type in section. The object that we're sectioning is the surface. Select that, hit enter, and then you can kind of, using the near O snap, you can just kind of snap to those construction lines that we just drew, holding shift. I'm just going to start drawing these sections across the surface like this. In fact, you don't even have to hold shift. If you got the near O snap on, you just kind of snap to the line and draw your section. It's pretty easy. We don't need those construction lines. I'm going to delete those because they get kind of distracting. I'm going to head back into this view and select sections and just mirror them around. And I'll have my completed cage. And I don't need this necessarily to model all those 3D sections because, I can get rid of those. Because I can mirror it around. But I like it because, again, if I wanted to do a drawing of the entire cage as a wireframe, as a continuous wireframe of the entire structure, I would then have those lines ready to go. Okay. And you can make a decision on whether or not you want to delete or just hide that surface. I'm just going to hide it. We don't really need it anymore. You can put it on a different layer, or you can just get rid of it. It's really up to you. But the surface has now played its part, and we're done with it. And if we look a little more closely, you can see now that I've finished off the cage. I've got my center lines for all of those tertiary structural elements that hold the skin. And if we turn on my primary beams, you can see that I've got a nice little offset away from that. And I should also have a nice float above our steel pieces. And that should give us enough clearance so that when we add a little bit of beam thickness to these lines, there's no intersection also there. Okay, a couple more steps, and I'm going to kind of go a little bit more quickly through these because they're getting repetitive now. I'm going to go to the beam curve. In this case, I'll make a new layer, call it Tertiary TER beam construction, so CON. Fire that one up and make it another color. Let's just say aquamarine or something. And what we do need to do now is, unfortunately, we have to do the perpendicular lines one more time, but only to the end point of all these blue lines. Okay, so I'm going to go line, perp, end point. You know the drill here. In fact, I'm going to make these a little smaller to keep it all clear here. Yeah, like that. And all we need is the end line, all right, the end point, I should say. Because we're going to use those to draw our section profiles again. So go ahead and do that. I'm not going to pause this time. I'm just going to run through it with you while you work. You can just kind of let this run for a bit. Change my view a little so I can see things a little bit more clearly. Yeah, sometimes it's hard to select a view that works for you, but just a few more to go here. So it's having a hard time snapping for some reason. Maybe it's the view. Try again. There we go. Okay, this is taking a little longer than expected. I am going to pause it here for the next 5 minutes and pick back. Okay, all of those perpendicular lines are drawn at the end. And now we just have to orient some cross-section curves. So I'm going to go to my front view. I'm going to draw in, by the way, I'm in my beam curve layer, the cyan one. I'm going to draw another rectangle at 6 inches by 6 inches. And I'm going to move it from its center point using that O-snap, if I can find it here. There we go. Go back to my perspective before I place it and start copying these at the end here, like that. And I'm going to just run through all of them and then rotate them in the next command. So just click them in there like this. almost there. And okay. Okay, the last step for here is to, we're getting close. Now we just rotate 3D. Like this, and set it to that line we just drew. Right, so we click it, the positive, or the holding shift in the x-axis again, clicking to the mid, rotating it up, clicking to that construction line so that they're perpendicular to the blue line, so that there's no mitering happening at the end there. They're all cut flat, or 90 degrees from the end of the blue section. All right. This one is easier than some of the other ones we did. Okay, I'm just going to pause for a minute. Okay, that's finished. And now I'm going to run into back to my layers over here, and I'm going to make a new layer, tertiary beams. Fire that one up and do my sweeps. So I can do sweep 1. The long blue rail is my... Oh, just before I do that, sorry. All I need to do, and this is simple to make everything really nice, is to just copy and mirror all those profiles that you just drew. You know, all those section curves to the other side, so we could mirror this thing around. Yeah, like this. All right. Mirror that from wherever over here. So now they're on the other side as well, because that'll make a better, cleaner sweep. And I guess while we're at it, we should probably also draw one from the midpoint. So let's copy this one over. Let's just find the midpoint of this blue line here. I'm going to turn off a couple things so I can see better. And that should be able to snap right to the mid there. Yeah. And the last thing I need to do before I start copying it is straighten it back out again, because it's... So I can use the gumball for that. Hold down the red one. That's not going to work, unfortunately. Never mind. Okay. Here's what we're going to do. We're going to have to just run that line. Actually, never mind. Just draw a simple line up like this in the front view or the side view from that midpoint, and straight up and down, and then do your rotate 3D like you did before here. There we go. Cool. So then you can copy and paste this thing at all the midpoints of the blue of the top blue section lines. You know, and again, just to keep things a little faster, I'm just gonna turn off maybe a couple of my O snaps here. Snap only to the mid, that would be helpful. There we go. There's one. There's another. And this is going to maintain a perfect sweep. You know, it's getting a little nitpicky, but I think to make a nice model, we've already put a lot of effort into this model. We should just do it the proper way here and finish it off. Mid to mid, easy. Let's see, I may need to turn on, oh, gotta keep going. Okay, and I'll finish it up in the middle here, like that. Okay, now we're ready to do the sweeps for sure, and they'll be really nice. So I'm going to go back to tertiary beams, sweep 1, blue line, and then my cross sections. Show you that one more time. Sweep 1, grab my cross sections in order like this, and we're drawing our curved beams, and they should maintain their continuous thickness all the way across, no problem. All right. Looks like I forgot a couple here, so I'm just going to mirror those. And you guys can go ahead and work. Hopefully this is starting to sink in terms of its repetitive methods. But because we have curvature in the system, unfortunately there's quite a bit of repetition if we want to model this properly. You know, because almost every section is unique. Of course, it's symmetrical, so you've got, but at least within the quadrants, they're all pretty unique unique curves, and they end differently down here, so you just have to do the rotations. Okay, I'm going to pause it here. I'm going to wrap these up, and then we're going to do the skin. Hey guys, just clicking back in just to show you also that, as it turns out, you only really need the one profile. You don't even need to mirror it or have them up at the top. That could actually speed you up a little bit. Turns out the sweep is a little more accurate than I thought. So you can just select the rail and one of the outer edges, like we do here, and it actually sweeps across nice and evenly right through the curve here without even needing to force it. So that's nice. So anyway, that's a little bit faster. It's not like we spent that much time modeling all those little cross-section curves or mirroring them, but future reference, I guess if you've got a pretty easy, simple form that you're sweeping around, and so long as this cross-section is perpendicular to the curve, you end up with a constant perpendicular, basically a constant thickness all the way across the curve, all the way to the other end without even needing to force it, which is pretty nice. Okay, I'm going to select that layer, tertiary beams. I'm going to cap these, add a little cap to the end, and turn on some of my construction lines again. And then I'm going to just select those there all the way down the line. Matter of fact, I could just start locking some of this stuff down here. Not just doing this. And then I'm going to mirror that around from here. Probably turn that one on real quick. Maybe that one. Okay. And there's my mirrored. Okay. All right, so all of my structure has been modeled. And I can turn all that back on again. You can see it all here. Structure has been modeled. No intersections there's a floating going on, and that's because we haven't modeled the brackets. Of course, this would make a pretty nice drawing. I mean, I don't think you necessarily have to force those brackets or those intersections to happen unless you have notching or something. And of course, if you're making a final project model, you may even want to show all those brackets. I'm just going to turn off the ISO curves just for the sake of clarity in the model. There you can see all the structure done here, completed. If we can get underneath it, it looks, you know, pretty similar to the building, I'd say. And it's quite nice. Very nice, clean model. Okay, last thing is the skin. And I'm going to run into my cladding layer for this. And we just need to do a quick offset so that we could connect our surfaces between these new pieces we just modeled here without intersecting once again. Okay? And to do that, we're going to just take the sections that we modeled as their center line and just offset them 4 inches. So I'm going to type in offset. The distance is going to be 4 inches. You can even leave it at 5 if you want. It doesn't really matter, so long as it's enough so that they don't intersect. All right, and I'm just going to take those blue lines and draw a new white line because I'm in the cladding layer now. Up and offset. You know what? You might not be able to see that very well, so I'm going to turn this just for this, just for the video. I'm going to turn that red. Maybe, yeah, red, I think you can see better. And you can now see the line that I'm offsetting from the blue one. So from blue to red in the right direction. That was the wrong direction. Let's turn off my tertiary beams here. Okay. Let's turn off all the beams. Maybe I'll keep the primaries on because that helps. All right, offset, curve, up, boom. Like this. And these are going to be the edges of the cladding, or the surfaces that are going to be used as cladding in this model. All right, so I'm offsetting all those blue lines. Unfortunately, you can't do this all at once. You have to run the command independently. That's just the way it is. Almost there. Looks like we actually are almost, yep, just 2 more. I'm just going to go to the midpoint at the center line again. And then I'll mirror the rest. Okay, that's good. And let's have a look at the curvature graph before we go much further. See how that looks. Yeah, it looks like we need to do a quick rebuild. No problem. So what I'll do is I'll take, let me see what happens if I select last. Okay, it only selects the one. So I'll just take, select all those curves that you just drew, and I'm just going to lock every layer to do this quickly. There you go. Type in rebuild. 10 is good. Click OK. These curves are now ready for surfacing. Check our curvature graph one more time. Yep. Nice. All right. Now I'm going to go back to a white cladding layer because now I'm going to add my surfaces and I want those not to be red. So here you could either sweep this if you had a cross section going across this way, but it's easier just to loft them. And that's what I'll do here. So I'm going to loft in between those sections there, like so. Leaving a little bit of a gap right above the primary beam. And that's it. So I'm going to go ahead and finish this with you. Drawing these kind of cladding strips like that. yeah. And I'm going to go back into I'm going to show those isocurves for this one because I like to see that. I think that looks nice. Okay, last step. Mirror them around. And this phase is complete. All right. And there you have it. You can turn on your structures. If you'd like, you can turn off all the other construction line layers and just have a look at what your result is here. Primary beams, secondary beams, tertiary beams. Everything is kind of offset from one another because we don't have the detail modeled. But I think that makes for a cleaner schematic drawing. And again, no detail that that holds in the cladding surfaces, until later on when that's figured out and modeled. But you can also see that there's no intersection there. It's all floating and looking pretty good, ready to be detailed. Okay, so finish this one up, and we'll pick up with a new tutorial using this base model as a form. But the next topic will be paneling and different kind of modeling techniques for 3D modeling different kinds of surfaces, different kinds of surface design, different kind of skin to structure relationships using this general form.